Okay.
So are you able to see the screen?
Yes.
So we'll start. So in chemical kinetics, it is a branch of chemistry which deals with the study of rate of reaction. So rate of reaction we'll write in short as ROR, okay?
Okay.
And factors affecting rate of reaction and the mechanism of reaction, how which it is proceeding. Next is mechanism of reaction. So these things we study. Now the first topic is rate of reaction.
Okay.
So in simple terms, it is just the speed of reaction, that how fast or slow a reaction is taking place. So rate of reaction, which can be written in short as ROR.
Yes.
So it is the change in concentration. You know what is concentration?
Yes.
What it is? So what happened in a chemical reaction, that reactants, they are getting transformed into products, right?
Okay. Yes. Yes. Yes.
In the starting, we have taken some amount of reactants, yes?
Yes, ma'am.
And with time, the reactant will go on converting to product. So the amount of reactants will decrease with time and the amount of products will increase with time, right?
Yes.
That means that concentration is changing with times because the reactants are getting converted into products. So the change in concentration of reactant or product per unit time,
Yes.
it is called as rate of reaction. That how the concentration of reactant or product is changing with respect to time. So suppose if we say, take one example, that initial concentration is 10. Concentration is simply number of moles per unit volume, okay? So the
Okay.
initial concentration of reactant is 10, suppose, and the products are 0 at the beginning because we have taken only reactants in the reaction mixture. Now with time, the reactants concentration will decrease and the products concentration will increase, right?
Yes.
So suppose it has decreased to 5. Okay, it has decreased -5. So the remaining concentration is 5. And
Yes.
so 5 reactants have been transformed into products. So that means the products have been formed 5.
5.
Okay. So it
Yes.
is the final concentration 5. And you should remember that concentration is represented by square brackets.
Okay. Okay, ma'am.
So if you are talking about concentration of R, we'll write like this. And if we are talking about concentration of product, we'll write like this. Okay.
Okay, ma'am.
And concentration is simple molarity. And what is molarity? It is the number of moles per unit volume.
Per unit.
Okay. And the volume of
Yes.
solution is taken as liter. So suppose the initial concentration of R, it will be written as Ri, that is 10. The
Yes.
final concentration of R is 5, right?
5. Yes.
And now we represent change with a delta sign.
Yes.
So this is change in concentration of R. Yes.
Yes. R by P.
So it will be final concentration minus initial concentration.
Initial concentration.
This is the change. So 5 minus 10 will give you -5.
-5.
So this minus sign is indicating that the concentration of reactant is decreasing with time.
Decreasing. Yes, ma'am.
And the concentration of product will be final concentration of product minus initial concentration.
Initial concentration of product.
So it will be 5 minus 0, that will be 5.
Yes.
Right?
Yes.
So this positive sign is there. When no sign is there, that means positive sign is there. So this indicates that concentration of product is increasing. With respect. Okay. Now we'll define some terms in this reaction, R is getting transformed to P. Reactants are getting transformed to P. So for reactants, we use a term rate of disappearance.
Yes, rate of disappearance.
So here the reactant is R, so we can write rate of disappearance of R. Or it is also called as rate of consumption of R, because reactants are getting consumed or they are getting disappeared.
Yes.
And the expression is minus of delta, that is change in concentration upon time.
Time.
Now
DT.
remember that rate of reaction is always positive. This term is always positive.
Okay.
And here you are seeing that the change in concentration of reactant is coming out to be negative, right?
Yes.
So to make it positive, we have placed a minus sign. Okay, so the expression of rate of disappearance of R is minus delta R by delta T. Is it clear?
Yes, ma'am.
Now for products, we'll use the term formation or appearance or production, because reactants are getting formed in the reaction or it is getting produced. So we'll use the term rate of appearance of P or rate of formation of P product, or it can be written as rate of production. Any term is given is any book, okay?
Yes, ma'am.
But in NCRT, rate of disappearance is used and rate of appearance is used. So you can use any of the terms. So it will be change in concentration of product with respect to the time. Okay. So these are the
Yes, ma'am.
expressions of rate of disappearance and rate of appearance. We place a negative sign in the expression of reactants and there's a plus sign in the expression of product. Because
Products.
rate is always positive. And rate of reaction is the change in concentration upon time taken. Okay.
Yes, ma'am.
Now, if this is the individual expression or likely of rate of appearance and of disappearance. But if we now write the rate of reaction, that is the ROR, or it can be represented as small r. So it will be minus of delta A by T, that means change in concentration of A with respect to time, and plus change in concentration of, sorry. If we have taken the reaction A to B, so it will be minus delta A by delta T. And
Yes.
change in concentration of B upon delta T.
Delta D.
Yes, and if we write in terms of this R forms P, then it will be minus of delta R by delta T and delta P by delta T. That means it is just the change in concentration upon the time taken. Okay.
Okay, ma'am. Okay.
So, do you have a notebook and pen with you?
Yes.
Okay, fine. I'll just give you one question and then you have to write a rate expression for it.
Okay.
So it is 2HI gas forms H2 gas plus I2 gas. Now write the rate expression for it.
Okay.
Write the expression for both the examples. Okay, and once you are done, please tell me. Have you done?
Yes, ma'am.
Okay, tell me the expression for the first one.
For the first one, it's minus 1 by 2 delta hi,
Okay, delta hi.
I by delta t
Okay,
is equals to plus dh delta h2 by delta t plus delta I2 plus delta t.
okay. So you have understood.
Yes,
It. Next one.
it's minus delta hg plus
Upon.
delta t, then minus c delta cl2 by delta t, then gives plus delta HgCl2 plus delta t.
Okay, now you can see here in the first expression. So this minus of delta hi by delta t. It is the rate of disappearance of hi, is it?
Yes,
And plus delta h2 by delta t, it is the rate of appearance of h2.
yes,
And plus delta I2 is the rate of appearance of I2. Same here, it is the rate of disappearance of Hg, rate of disappearance of Cl2, and this is the rate of appearance of HgCl2. Okay,
okay, ma'am.
now, and here also it is the rate of disappearance of A, and it is the rate of appearance of B. And here also it is the rate of disappearance of R, and the rate of appearance of
T.
B. Now you can see here in A to B reaction, the stoichiometric coefficient is 1. Yes or no?
Yes,
And in the second example also R to B, the stoichiometric coefficient is 1 of both reactants and products. And in this example also the rate of react, the stoichiometric coefficient is 1. So in these three examples, this one, and this one, you can observe that the rate stoichiometric coefficient of the reactants and products are same.
same.
So we are seeing that the rate of appearance or the rate of disappearance were the same. That's why they were coming out to be equal. And here also. But in this one, where the stoichiometric coefficient, they are not the same. Then you are seeing that the stoichiometric coefficient is getting divided, it is coming in the denominator.
Okay, ma'am.
So now we'll discuss the examples in which the stoichiometric coefficient of reactants and products are not equal to 1. So this was the example. So for such type of examples or the questions, you have to divide the rate of disappearance or the rate of appearance by their respective stoichiometric coefficients. Okay, I'll
Okay,
just give you one example. So if you write the general example, AA plus BB forms CC plus DD. Now the small a, small b, small c, and small d, these are the stoichiometric coefficients. Okay.
okay, ma'am.
So when you will write the rate expression, and you have been told to write the rate expression. So you'll write R is equal to, first you'll write the rate of disappearance, and then you'll divide that with the stoichiometric coefficient. So stoichiometric coefficient is A, so you'll write minus 1 by A, delta A by delta T.
Okay,
And it will be minus 1 by B, delta B by delta T. And in the product, you'll place plus sign. So it will be 1 by C, delta C by delta T, and plus 1 by D, delta D by delta T. You just have to remember that the stoichiometric coefficients will go in the denominator. Is it okay?
yes, ma'am.
Okay, now I'll give you one question to write down the expression. So it is 5 Br minus plus to write down the rate expression. Have you done?
Yes, ma'am.
Okay. What have you written?
Yes, but I have a doubt.
Yes.
The minus 1 by A in AB plus BB. So in this,
The stoichiometric coefficient will come in the denominator, okay? And for the
yes.
reactants, you'll write minus sign. So minus sign is there.
Okay, but for this example, should I just separate like you wrote minus delta BR by,
Like, I'll explain you. So it will be minus 1 by 5. The stoichiometric coefficient will come in denominator.
yes.
And you'll write the same, delta BR minus by delta T, okay? For the next one, the stoichiometric coefficient is 1. So you'll write minus delta BR O3 minus by delta T.
Okay,
Is it
okay. Yes, yes.
Then it will be minus 1 by
Minus
6.
1 by 6 delta H by delta T.
Yes. Just you have to remember that the stoichiometric coefficient will be in the denominator, and with the reactant you place a minus sign, with the product you place a plus sign.
Okay, 1 by 3 by delta BR by delta T plus 1 by 3 delta H2O plus delta T.
So are you clear with the writing of expression?
Yes, yes.
The next subtopic is units of rate of reaction. Units of R to R. So the reactions were getting transformed into products, and if we write the rate expression, it will be minus of delta R by delta T or delta P by delta T. So you are seeing that in the numerator concentration is present, yes,
Yes, ma'am.
and in the denominator time is present.
Yes.
So if we have taken the concentration in mole per liter, because the unit of concentration is mole per liter, and the unit of time is second, okay?
Okay.
So the unit of rate of reaction will be mole per liter per second.
Okay.
And in some books, mole per liter is written as capital M, because mole per liter is the unit of molarity. Because molarity is equal to number of moles upon volume, and the unit of number of moles is mol, and the unit of volume is liter. So it can be written as mole per liter. And this mole per liter it is also called as molar, and the symbol for it is capital M. That's why in place of mole per liter, somewhere capital M is also written, and along with it per second. So the unit is mole per liter per second. Okay.
Okay, ma'am.
Now, if you have taken gases, so for gases we talk about partial pressure, right? Yes or no? For gases we take their pressure.
Yes, yes.
And the unit of pressure can be atm, and the time is in seconds. So the units in for gaseous reactions. For gaseous reactions, unit of rate of reaction will be atm per second. Or if it is given in bar, it will be bar per second, because atm and bar are the units of pressure, but in NCERT, atm per second is mentioned, okay, for gaseous reactions.
Okay, ma'am.
So these are important units. So this was pressure upon time. The unit of pressure is atm and the unit of time is seconds. So you are done with the basic definition of rate of reaction, the units of rate of reaction. Now, do you know about types of rate of reaction?
Yeah, wait, you mean rate of disappearance, rate of appearance?
No, that was different. That was in terms of reactants and products.
Types, like,
Of
can you just...
rate of reaction. So the first one is average rate of reaction. Remember?
Okay, average rate of reaction and instantaneous rate of reaction.
Yes, correct. So average rate of reaction is the change in concentration of reactant or product in a fixed interval of time.
Okay.
So like if I draw the graph,
Delta X by delta T.
yes, correct. So you know that in the beginning, the concentration of reactant is very high. The maximum value is there. And with time, the concentration decreases, right?
Yes.
So on the left-hand side, we have taken concentration, and on the x-axis, we have taken time. And here, it is the maximum concentration. Now, with time, you can see that the concentration is decreasing. So suppose we have taken 2 times. One is T1, and after some time, it is T2. Now you can see at T1, the concentration is C1, and at T2 time, the concentration is C2.
C2.
Okay, and now you can see that concentration 1, C1 is greater than C2. And you can see that with change in time, the concentration is decreasing.
Decreasing.
Yes,
Yes, ma'am.
that's why the graph is like this. And if we draw it for the product, it will be the concentration of product increases with time. So we have to draw it like that. So it will be like this. The concentration of product is increasing with respect to time. Are you clear with the graphs?
Yes, ma'am. Yes.
Okay, so this is 91 and this is time T2. Concentration is C1, the concentration is C2. So you can see that the concentration of is increasing with time, right?
Yes.
Now the slope of this curve. Slope, you remember delta y by delta x.
Yes, ma'am.
So the slope of the curve gives the average rate of reaction. So our average will be equal to C2 minus C1 upon T2 minus T1.
Minus T1.
And you can see that the concentration is decreasing, but the rate has to be positive always. That's why we'll place a minus sign for reactants.
Okay, ma'am.
So this graph is for reactants and this graph is for products. So here our average expression for products will be C2 minus C1 upon T2 minus T1. Is it clear?
Yes, ma'am.
So that means average rate of reaction is the change in concentration of reactant or product in fixed interval of time. You can see
Okay.
that we are talking about a fixed interval of time, which is written as delta T. So
Yes.
this is for a fixed interval of time. Now the next one is instantaneous rate of reaction. As the name suggests, it is the rate of reaction at a particular instant of a time, at a particular moment of time. So next one is instantaneous rate of reaction. So if the rate of reaction is calculated at a particular instant of time, it is called as instantaneous reaction. And if we'll talk about a fixed interval of time, it will be called as average rate of reaction. Okay.
Okay, ma'am.
And you know that whenever a change in quantity, like suppose if we talk about change in time, if the change in time tends to 0, that means it approaches to 0, then dt will get converted into dt. Delta t will get converted into dt. Okay.
Yes, ma'am.
So now the same graph is there for reactants and products. Just now we'll calculate the slope of the tangent. So the graph is like this, and we have to calculate the instantaneous rate of the reaction at a particular time. So we'll draw the tangent at a particular time. Okay, suppose we have to find out the speed of the reaction, the rate of the reaction at this time. So at this point, we'll draw a tangent to the curve. So this is the tangent to the curve.
Oh, okay.
Do you know what is a tangent?
Yes.
Tangent is a line which intersects the curve at only one point. So it is intersecting here only. So here it is concentration, and on the x-axis it is time. So now the instantaneous rate will be RINST minus dx by dt.
Okay.
Suppose there is a change in concentration. This much is the change in concentration, and this much is the change in time. So only minus dx by dt, you differentiate it. Now, if we draw the curve for the product, it increases, the concentration increases with respect to time. Here also you'll draw tangent to determine the slope of the curve. So suppose you have to draw here. So you will draw tangent, a straight line passing through this point, and then using that value, you can tell the instantaneous rate of product. Is it clear?
Yes, ma'am.
So this you have to remember that instantaneous rate of reaction it is equal to the slope of curve. Okay,
Yes.
that means in the numerator you'll write the intercept on the y-axis. This is the intercept on the y-axis till here, and this is the intercept on the x-axis.
X-axis.
So intercept along y-axis upon intercept along x-axis. So it can be written as minus dx by dt or dx by dt. And the formula of slope is tan theta. Do you know this?
Yes.
Okay. And theta is the angle made by the tangent with the
Tan.
positive x-axis.
Okay.
Theta is the angle of tangent with positive x-axis. So here on the x-axis we have time. Okay.
Okay, ma'am.
So this was about the two types of rates of reaction. Now, do you have the book with you?
Yes.
Okay. Open page number 100 in text questions.
Page number?
100. 4.1 in text questions.
Yes.
So the first question is for the reaction R to P. Reactants is getting transformed to P.
Yes.
And it is given that the concentration of reactant is changing from 0.03 molar to 0.02 molar in 25 minutes.
Yes.
Okay. So you have to calculate the average rate of reaction because a fixed time interval is given 25 minutes. So you'll calculate the average rate of reaction using units of time
Okay.
in minutes and seconds. So what will be the expression for rate of reaction? R will be equal to minus of delta R by delta T, right?
Yes.
And you have been given the concentration of reactant.
So,
So you have the minus sign with you, right?
yes.
And change in concentration is the final concentration minus the initial
Minus
concentration.
initial concentration.
So 0.03
Zero.
molar is the initial and the 0.02 molar is the final. So you can
Final.
write that minus of change in final concentration minus initial concentration upon
Divided by delta T.
Okay. Now you can substitute the values and find out the answer.
Okay.
So you tell me the final answer in mole per liter per second. Okay. So you convert this time into seconds. Have you done?
Yeah, it's 4 into 10 raised to minus 4.
Okay, but the unit will be mole per liter per minute because you haven't changed the time into seconds,
Okay,
right?
okay, seconds. Okay.
So this is the answer in moles per liter per minute. You have to report that also. Now you convert that into seconds. Okay.
Okay. Is it 6.6 into 10 raised to minus 6?
6.6 into 10 to the power minus 6. Okay. And the unit will be mole per liter per second. Okay.
Yes.
Now we try the next question. Question number 2. And here the reaction is given as 2A forms product. So first you have to write the rate expression. And you can see that the concentration of A is decreasing from 0.5 molar. Molar means mole per liter, capital M, to 0.4 mole per liter. And it is taking place in 10 minutes. Now you have to tell the rate of reaction.
Okay. It's 5 into 10 raised to minus 3.
Yes, but what is the unit?
It's in minutes, right?
Yes. So you must have written like this, minus 1
Yes,
by
1 by 2
delta.
delta A by delta
And then
T.
then you would have got the answer, right?
Yes.
Good. Now the next topic is factors affecting rate of reaction.
Excuse me, ma'am, I have to go.
The time is up.
Yes.
Is it 5:30 at your place?
Yes, 5:30. It's 5:36.
Okay, no issues. We'll continue in the next class. You just revise till this topic, the rate of reaction, the introductory
Okay,
part,
so
and
next.
solve the example and the in-text questions. Okay. And
Okay.
I'll inform them that to schedule the class between 4:30 to 5:30. Okay.
Okay, ma'am. Thank you, ma'am.
but you joined the class on time from